So thanks for joining us. My name is James Labocki. I'm the product manager for Red Hat Cloud Infrastructure, which is a combination of CloudForms, Red Hat Enterprise Virtualization, and Red Hat Enterprise Linux OpenStack platform.
Vamsi, Chief Architect for Red Hat for the East.
Jey Paulraj, I'm a Senior Solution Architect for Process Management.
Yep. So what we want to do today is talk to you guys about intelligent business management in the cloud. So what we did is we kind of mocked up a scenario of Acme Corporation, right? So this is something that we think we've kind of seen happen in the past with customers, and so we wanted to take this as a scenario and see how we could solve this problem for the customer. So during Acme Corporation's peak season, its e-commerce application was overwhelmed with requests, so that slowed the application response time. The operations teams, they were notified, but it was a slow response. So the system administrator has to call the line of business user and find him and call him up, and all that stuff has to happen. At the same time, the operations teams reacted by providing more capacity. So they said, okay, this app is going too slow. We're going to add a couple more application servers to the pool and do this. But they went ahead and picked an infrastructure as a service platform and then deployed their application out of there. So a couple of problems with this. The first is a loss of revenue. So since they had a high time to recover from the e-commerce slow response time, they basically started to lose money. They also increased their costs. So the infrastructure platform that the operations team selected was of higher cost than another one that they could have used. The third is that they increased their risk. So it turns out that the operations team actually picked a platform that was not PCI compliant. So they ran into problems there. The fourth is they had increased process complexity. So there was really no separation between the business, what the business rules were doing, and the actual implementation of them by the operations team. And the last one is they had a lack of control. So they were unable to determine the workload placement with a context of the business. So there was no understanding of the business to react to this. So what if the cloud management platform was able to actually respond in a business context for this? So basically, if the cloud management platform could respond to these events, if they could also allow for complex business workflows, if it could manage the workloads with the business in mind, and if it could actually rapidly adapt to the business changes. That's kind of the questions we were asking. So,
Great, thanks, James. So as we start working with a lot of Fortune 500 type companies in the cloud space, with Red Hat's acquisition of CloudForms and some of the capabilities around Red Hat OpenStack, it becomes pretty clear to us that IT shops are looking to do the first level of maturity, which is to build the plumbing underneath their cloud. Once you do that, it's all about applications and workloads. And applications are really where your company starts or does better or generates more revenue versus your competitors. And we start pulling these concepts together, it becomes extremely clear to us that there's a concept of application-driven cloud. The cloud itself should be driven by line of business users or the folks who are paying for applications to go on the cloud. So in our portfolio, we have two jewels, right? Really good products. The first is CloudForms, which is our cloud management platform, which James is going to talk about in a few. And the other being the JBoss Business Process Management System. So the BPMS, as it's known, is an umbrella technology which brings together business rules, business processes, and an ability to intercept a stream of a cloud of complex events and to be able to detect patterns based on rules that the business has defined. And BPMS itself has been deployed in virtually every large industry vertical. Tons of deployments in financial services, healthcare, insurance, retail, et cetera, et cetera.
all right.
So just to level set, what's the CMP and what's the BPMS, right? Talk about where the BPMS is first. As I mentioned, sorry, yep.
Yeah, no, so on the CMP side, so a cloud management platform is really a platform that provides these types of capabilities on your infrastructure. So things like discovery, being able to discover what infrastructure is out there. So this could be, in the context of CloudForms, discover your VMware environment, Amazon Web Services, Red Hat Enterprise Virtualization, or OpenStack. Providing capacity planning, so taking the actual data that's coming out of the infrastructure platforms and then go ahead and allow you to do capacity planning. So for example, looking at a certain pattern workload and determining how many of those you can fit on a platform. Reporting, so being able to actually report on those environments. This is doing things like VM introspection, which we'll do some demos later and show you kind of how these things can play into the BPMS as well. Audit and compliance, so again, being able to introspect the disks of the instances or VMs, and in the future even containers that are running on these platforms and begin to understand what's running in them and when. Analytics, so this is being able to drive how your platforms are performing. And then monitoring as well, so this is basically generating events and sending events out to external sources based on what's happening in the infrastructure. Orchestration, so being able to deploy through a self-service catalog and orchestrate a complex application deployment. Policy, so being able to build rich control policies that allow you to build out how you want to treat workloads and how you want to respond to those events in your infrastructure. And finally, of course, chargeback, so getting actual and allocated usage out of these platforms, rolling them up into the CMP. That's basically what a CMP is, a cloud management platform, and that's exactly what CloudForms does. How it does this is actually through, with regards to CloudForms, is it actually has a virtual management database. So basically, inside the VMDB is where all the relationships, configuration, performance, audit, and drift are stored. Along with that, we provide role-based access control, an automation engine, and a control surface. And then one of the keys is really the abstraction layer. So this allows us to plug into all the things you see down on the bottom. So whether this is NetApp for storage, an F5 load balancer, various infrastructure platforms and providers, as well as all the workloads you could deploy, and then even configuration management language like Chef and Puppet. So this is CloudForms is actually shipped as just a virtual appliance. So you deploy it into your virtualization provider, whether that's Rev or VMware as a OVA or OVF. You can deploy it into your OpenStack environment. So we ship an image that you could drop into Glance and spin up, and it will actually federate between the different appliances that are running. So you could deploy multiple appliances, and they'll pick up jobs and act as workers in the various zones that you set up. So. All right. Hand it over to you.
Thanks, James. So if you look at what a BRMS or a BPMS does, right? So one of the cool things about the way Red Hat's looked at this technology, and if you compare it with the competing products from some of the proprietary vendors out there, our business process management system is essentially a business knowledge management system. And we define knowledge as three different things. The first one is business processes themselves. So a business process is a set of actions that are done by the actors in your enterprise. So if you're a large retail company, you have a few roles, right? And the idea is that every organization is composed of business processes that are done day in and day out by employees. So the first type of knowledge that we manage is business process knowledge. So you essentially use the BPMS to automate any process that's manual. And because it's manual, it could be error prone. And it could also be error prone in that things don't get on time. SLAs are breached because you have human actors in the loop and things of that nature. The second is business rules. Business rules are basically constructs that can be modeled in terms of an if-then-else type model. The issue with basically embedding a lot of these business rules in your application code is that anytime the business changes because of market conditions or requirements that change, the application code has to change. And you've got to go through pretty complex, rebuild, deploy cycles, which don't exactly make you agile, right? Because you're touching multiple systems in a business process context, and you incur a lot of downtime and things of that nature. So the goal with the rules-based approach has been to carve out all such logic in your applications, which deals with anything of the type if then else, right? And then to make them available in a rules engine, and that this rules engine then takes a life of its own in terms of having a full life cycle on development and deployment. And the idea then being to have a non-technical user be able to edit the rules and to be able to deploy them, right? So you have things like decision tables, which are Excel spreadsheets of your rules that can be pulled into the BRMS, and also domain-specific languages. These basically are things around your domain itself. And if you look at how the BPMS describes a business process, it's in an industry standard notation known as Business Process Management Notation, BPMN 2.0. That's the latest release. But you also can basically define what are your domain-specific constructs and make them available to analysts so they can write English, essentially, of how to react. If there's a certain breaching workload, how to react to that, right? Shut the machine down or basically spin up a cluster in a different cloud provider, et cetera, et cetera. But the important thing here is flowcharts. So the BPMS approach is basically around flowcharting. It's to basically take away the IP that a lot of business folks have and to make it available in a simple flowcharting-like language. So you have a palette of different nodes that you could choose, and your business owner can basically drag and drop these things onto a canvas, right? And the way we do it, if you look at our product, is we cater to different types of audiences, ranging from more technical to less technical. So most organizations that do this approach basically have a mix of technical to non-technical rules and processes. And as you start getting more mature in your usage of the product, you start moving from the left to the right. And the nirvana is that you end up giving your business analysts full power to define what these rules are, what these workflows are. The other capability that we have is collaboration. Since you're going to be defining business rules and business processes, you're not going to be doing so in a vacuum. There's going to be multiple people who are part of that project. So we include a repository, and we also have other cooler features in terms of versioning. You basically can define multiple versions of a business process and make them available in the BPMS, which has historically been a bit of a challenge for tightly coupled products like maybe cloud management platform, right? The other thing to keep in mind is when you start developing in a rules-based approach, it is never, you basically have a life cycle which is a little different from typical application code. And the way I like to think about this life cycle is you first develop, and then you develop, you model, you deploy, and then you basically refine it based on the feedback you're getting from the business. And in the JBoss BPMS product, there's tools around simulation, so you can actually see how a process would work in real life and then optimize it based on a certain business condition being met or not met. So again, just to sum up from pretty high level, looking at the product and what's contained in the BPM suite. As I mentioned, it's not a single paradigm that we're trying to solve here. It's a suite of products, but they all look and behave like one product. They're all based on what is known as a Drools open source community project, and we are the enterprise counterpart here. We ship a container which is either a standalone Java container. So when you want to deploy these rules, you have a couple of choices. You could either take these rules and embed them in your application. So if you have an application that currently uses a WebSphere, WebLogic, or a JBoss, you don't have to perform heart surgery on your application to be able to incorporate workflow and business rules. But if your choice is you want to make it available as a standalone cluster of servers, you could go the route of a decision service. So the first technology is the business rules engine, right? It goes in there, it provides you declarative business rules. So you can define your rules in all the different notations that I spoke about in the previous slide, either decision tables or DSL or even a web editor. And then you have the business process engine itself, which is based on the JBPM 6 project. And then the other cool project here is complex event processing. So CEP is this notion that this space where it's pretty prevalent in financial services. You have a stream of events that you want to listen to, but you don't really care about 98% or 99% of the whole stream. You're looking for those sub-patterns in the stream which map to what your business challenge is, and you want to react based on that. So a big example is, you have a financial trading application which makes a decision to buy or sell stock based on how certain stocks are trading. So you could have a rule saying that if IBM beat estimates by 2 cents a share, then you want to go ahead and buy Red Hat, right? That's a complex rule because you're going to be looking at a bunch of events that are all the trading data for that day, and you're just looking for that ticker based on a certain time of the day, right? You could extend this paradigm to the cloud as well. You have a cloud of events that are being sent in by your CMP or by virtualized infrastructure. You could have the BPMS basically intercept these streams and look for any pattern that matches a certain application or a certain workload, and then do what you need to do, right? Not all workloads are built the same, right? You can basically have that coded in the CEP part of the application. The other couple of things, we also include modeling tools. So you can use a browser-based tool to define these workflows, business rules. But for those of you who are more developmentally inclined, so this is in more complex rules where you need to write some code to make stuff happen, right? You'd basically use something like the JBoss Developer Studio, which is an Eclipse-based IDE, and we provide plugins to these projects. But the important thing to keep in mind is that there's a unified API for all of this. So once you deploy your rules, your BPM onto your container running JBoss, and you stand it up in your cloud, your apps can get to this using a simple REST call or a SOAP call or whatever standards-based call there is. So the idea has been to keep the disruption as minimal as possible to your existing architectures. Most CMPs support some kind of web service, right? So it's a fairly easy thing to begin using the BPMS for intelligence in the overall system. So from product perspective, you look at the deployment architecture. Again, you have different groups of users or communities of users. Business analysts, these are people who are who want to write cloud-based rules, but they want to do that using some kind of a drag and drop editor. You have developers who want to write more complex rules based on how they want to place certain workloads. And then you have business users who want to look at dashboards of how a certain cloud is doing or how a certain process is working, right? So they all of them log into the engine using a browser-based interface, which we're going to show you in a few. And then you have in the middle the business data itself and the engine working in its own container. And the right end, you have the business users, right? Or any kind of system that wants to get to a business rule, fire a business rule, or invoke a business process. So these systems get to our product using standard interfaces. So one of the other things we embed here is something known as Apache Camel, which is part of the JBoss Fuse line of products. And it's a mediation engine, but it's probably the most robust engine out there in terms of the wide variety of endpoints it supports. So we embed Camel with the BPMS. So you could get to it using any of the endpoint protocols that Camel supports, FTP, SFTP, HTTP, so on and so forth. You can even plug in your own custom ones. The other thing is the web-based authoring, right? So I have an example here of an insurance policy, but again, you look at those terms there, the driver, the policy, surcharge, these are all what are known as your fact object. And you can essentially model this in your cloud as well. So all that the BPMS needs to do is to be able to understand your infrastructure and the fact objects around infrastructure. And once you do that, you could basically write a rule saying there's a cloud with capacity that's more than, 2,000 vCPUs, and there's a workload, and the workload has a requirement of X CPUs, X memory, then allow permit workload to be deployed in the cloud, right? That's an example, but that's how it would work.
All right, so basically what we want to do is, we kind of built this visual out to help guide you guys through as we're going through these scenarios, because there's a couple of different user interfaces you're going to be seeing. So we're going to kind of refer to this as the scenarios. So in the beginning, we talked about Acme Corporation, right, and the problems they faced. So really, if you look down at the bottom, what you have there is your infrastructure as a service, your platform as a service, your SaaS, right? So those are your cloud platforms, and there's an operations user that probably interacts with those directly, right? He goes and provisions new hosts, adds them to the pool, provisions new platform as a service nodes and those sorts of things. In the middle, you got the cloud management platform, which could certainly service self-service users there. And there's also a cloud management user that would be using that. So the CMP has all that kind of placement policies, alerting profiles, capacity and utilization, and a portal itself. But then above that is where the BPMS comes in. So that's really where the business user goes, right? So in the Acme Corporation example that we were going through, what we wanted to do is figure out how do we notify the business user of events taking place in the infrastructure intelligently. So not just some random alert that he gets and he doesn't understand, but how do we actually give him context? So without the BPMS, the business user is basically out of luck, right? If there's an alert that happens down in the infrastructure as a service, PaaS or SaaS, he has no idea what's going on, right? He has to wait for the cloud management user to give him a call. But even if we do alert and tell the business user about this, the alert he's going to get doesn't have any contextual information. So what he's going to get is my VM, my virtual machine CPU is at 85%, right? And at that point, he's probably going to get even more mad, right? Because now he's just got this information and he's going to call up the cloud management user, right? Which is probably half of you guys, right? And start yelling at you, what's this mean? Is everything okay, right? And I guarantee you it'll be on a Saturday, for sure. So the key is to give the business user notification alerts with rich contextual information that they can understand. So the goal here is that we would pass the alert for the VM, a VM CPU being high in this example up to the BPMS, and then that would translate it into something that the business user could understand, right? And in doing that, we also start to provide a place where we can start adding business logic that's not in the cloud management platform that we could change dynamically. Right? So, quick demo. It's live demo, guys. It's always fun. All right, so let's see, what do we have here? So I'm going to go ahead and...
Have most of you seen CloudForms yet?
Yeah, that's a quick show of hands. Who's seen JBPM's user interface? Who's seen CloudForms user interface?
No.
How many of you have seen Rev? OpenStack's user interface. All right, cool. So we'll go through it slowly, give you guys a quick overview of that too. So,
Sure.
All right, so the first scenario again is what we want to do is trigger an alert from the cloud management platform. So this is the CloudForms management engine UI. I'm going to go ahead and log in. And what CloudForms management engine gives you is basically, when you first log in, it's all role-based access control and dynamically tagged. So this is completely customizable what the user sees. In this case, I just logged in as the administrative user. But if I logged in as a self-service user or a database administrator, I can customize this whole view for them. Basically, under the Cloud Intelligence tab, you're going to see reports, chargeback, timelines, things you'd expect from an IT operations management tool for cloud. You also have a services tab where you can see the services that you have already ordered and are running. You have a self-service catalog. You also have workloads and requests, so you can actually see requests that have come in as your username. You can also see your cloud provider. So if I go drop onto here, I could see, I've defined under cloud providers, I've defined actually an OpenStack and an Amazon provider. And so CloudForms will go out and start to, discover all of the workloads that are running, all the instances running in Amazon on this user's behalf, and then also all the workloads running on OpenStack under this user's behalf. And then under the infrastructure side, I've added two providers, a Rev provider, Red Hat Enterprise Virtualization, and a VMware vSphere provider. So I can see those here. You'll also notice there's control policies. So what I've done inside of there's plenty more we could dive into here, but for the purpose of the demo, if I go to the control policies, this is where I can actually start to define policies based, complex policies that I can use to control my infrastructure, whether it's a cloud provider or a virtualization provider. But what I've set up here is just a simple alert. So if I go to alert profiles and select my alert profile that I created, underneath here, basically what I'm saying is, if a VM instance has real-time performance, and the CPU collected intervals is greater than 95%, I don't care if it's trending, so I can put trending information there. I'm just going to alert, basically. And so what's going to happen is, first it's going to send an email to me, the cloud management user, but then it's also going to send this event name into the automation model of CloudForms. And basically what that's going to trigger is a web service call to the BPMS, JBPM. And so that'll actually kick this thing off. So I was going to try and spike the CPU with DD to dev random or something, but I figured it's probably easier to just do something and simulate it instead. So if I drill into my actual provider and go grab my virtual machine here, all right, so here's my Rev provider. We'll go ahead and select Summit 14 guest VM. All right, so here's my virtual machine. And what I've done is I've just created a button on this VM that basically simulates the fact that the CPU would be high on this VM. So what I'll do is I'm going to go ahead and trigger this fake CPU spike number 1. And then I'll hand it over to Jay, and he'll show you what it looks like when it lands in the BPMS.
Okay. The PPM is a unique platform where you can model your process and both command type, runtime, and design time your application. I can show you how we trigger the process based on the event coming to the engine. Okay, this is the PPM application. If you look at here, it's a unique platform where you model your process, deploy your process, and manage your process, as well as manage all the activity, what happened inside the PPM engine. So when he triggered the event through a REST API, PPM engine consumed the event and triggered the notification to the customer service or email notification. The first scenario is send an email to the customer service.
Bring up my email.
Oh, you want to show them the process?
Okay. So I built 3 processes for 3 scenarios. The first process just send the email notification to the customer. You can receive the event. Based on the event, it just format the event content and massage into the proper format and send to the email. Anybody's email?
Yeah, I'm gonna show my email.
Yeah.
Oh, let me log in. Sorry, I must have dropped it. All right, so let me actually.
So the business process takes the data, does some massaging to the data, looks at the fields, and then sends off an email to James's console or the user's console, the business user's console.
All right.
Yeah, it's to receive the event and collect the meaningful information and format it according to the business user context.
Yep. So basically, this is notifying him that the transaction processing is delayed, right?
Yep. So you want to try the next scenario?
Yeah. So in this context, this is just an example, but certainly the BPMS could take into account all the tags that are on that VM as well. So just to quickly show you, if I were to actually go into this engine, you'll notice that this VM is actually tagged with all this metadata, and that's getting passed to the BPMS. So the fact that this is in Boston, the location is Boston, and the service level is gold, and it's production, and the department is financial services, and the service that it's associated to is transaction processing, it can pass all that metadata from the VM up to the BPMS, and then the BPMS can then basically construct decisions based on what that information is to then alert the user, right? So we might have multiple escalations, start going up the chain of command. All right, so let's, let me flip to the next one here. I was supposed to take this off, sorry.
The first is just email notification. The second use case, based on the event, the BPM engine extract the event and route it to the custom human interaction.
Yep. All right, so the next one is, you want to take this?
Sure.
Yeah, go ahead.
So this one is about how do you respond to an infrastructure event that's happened with the business context in mind, right? If you look at this example, you have the cloud management platform that sends out information about a breaching event, maybe a VM or a service that's running on a bunch of VMs and CloudForms has breached a certain threshold, and you know as a result that the e-commerce application is degraded, it isn't functioning the way it should. And if you send such an event off to the business rules engine, you could have a pre-programmed rule in the business process engine, a rule and a business process themselves, which say that if you receive such a notification from cloud A or B or C, you want to go and request a new VM, right, on a certain cloud. So once the business rules engine gets the request that the e-commerce application's performance is degraded for whatever reason, it can, based on that predefined rule, dynamically go out and request a new VM as part of the provisioning process around CloudForms or the cloud management platform to go spin up that new VM in an infrastructure service provider, right?
Yeah. Okay.
So again, as a result of that, you basically then can notify the business user that the e-commerce application has been healed and it's starting to perform acceptably or stick to a certain SLA or response time.
Yeah, and so the idea here is, the CMP really has, the cloud management platform can do the implementation, right? But we want to put the business logic up into the BPMS, right? Because as we do that, then the line of business user can begin to change his mind on how he wants to scale, when he wants to scale, and do those sorts of things. Right. And he doesn't have to call the cloud management user to say, go ahead and please make this change inside of the CMP. All right, so let's go ahead and, so we'll go back to that same VM, and in this case, what we're going to do is we're going to go ahead and simulate the fact that the CPU is spiking on this again. So I'll go ahead and select that, and you'll see that basically the method was executed. So what's going to happen now is inside of the JBPM suite, we should see this happening.
Yeah, the JBPM received this event and kick off the process from the engine, and it sent a notification to the user as well as it needs the human interaction, what the user want to do it after that. So go to the human task and enter the information, what the server they want to bring it up.
Yep. So now you'll notice if I'll go back to here. So while he's switching that, this is the request screen inside CloudForms where you could see new requests coming in for VMs. So we'll show him this, oh, here.
So where's the email? Yeah. So we got the email. This is to notify that the transaction process system is degraded. So what's the application server, what location, what's the alert. So you got the notification. Then the customer service user log into the BPM system. When you log in, the task is assigned to the customer service department. So it's not assigned to the single user, it's assigned to the role. So when they log in, they claim the task, then they do the activity.
Right, so to that point, right, in the BRMS or the BPMS, which is now the umbrella product, you basically can define pretty complex business workflows with, tens of states. And in that, you also can designate what are called swim lanes, which are users. A swim lane is a set of users who are in a certain group. So you have a group of operators, a group of line of business managers, you could have a group of cloud admins. And to Jay's point, you can basically define a set of escalations. If a certain user does not pick up a certain task, it can then go to the other user in that swim lane. And once a user, and you also can set up an SLA saying that if no one's picked this up within 10 minutes, then escalate this to the higher management, right? Or a cloud admin or whatever have you. You can define that the whole complex chain of people who should act based on a given business workflow.
So once you got the notification, it assigned to the role, which is a group of the department. So any user belongs to the department, they can log into the system and they claim the task. So when they claim the task, it's assigned to the particular user. Then they do their activity. So I can go back to the task. As I told you, this is a unique platform where you model your process and rules, where you manage all the process execution. So this is my process, this is my development. The same tool, I can go to my task.
So what Jay has here is a pretty simple workflow. You can actually define workflows that are way more granular, way more complicated.
So look at here. Okay.
Jay, should we explain what a task is?
Yeah.
Yeah, that's where it is.
Yeah. So if you look at the different nodes that make up your business process management notation, there's a notion of what are called tasks. This is where a human is involved in the loop. And once you drag and drop a node that is of task type and you paste it in the canvas, you can then define a form that the user is going to see when they log into their system that notifies them that a certain conditions happen. And the business process actually pauses at that task so that the user then has to go in there and say a yay or a nay or do whatever they need to do. Or if nobody does it in a given period of time, it gets escalated. So before Jay explains further, you could do this in conventional code itself. But the real usage where a BPMS shines is when you have thousands and thousands of power processes. The engine can basically dehydrate what tasks are not being, or what processes are not active because they're waiting on a human actor, and then use that capacity for other processes. And when the user gets back and they do something they need on a Monday morning, typically, right? If a task has been sent on Friday evening, 8 p.m., but nobody logs until Monday morning, the engine can basically take that whole state of the process and dehydrate it in memory, right? Put it on disk so that it doesn't tax the server.
Yeah. So the human task is assigned to the group. So the user belongs to the group. They can log into the system and they can choose the task. And the task itself has escalation. If the task is not happening within a particular time frame, it can escalate to a supervisor. Or you can keep on putting the chain of, okay, this task has been pending for 5 days. It needs to be done as soon as possible. You can keep on sending the notification through escalation. So I got the task. Since I sent the role, I can work on it. I have to claim the task. That's why here's the log here. Once you claim the task, you release the log, then you can work on that one. No other user can work on this task. So I claim the task. I can go to the detail of the task. So work detail. This is where you see all the information, what the customer service can work on it.
And the other thing to mention is you don't have to use the UI we provide. You could basically roll out your own using whatever UI technology you like, Flex or whatever have you, right? What we've focused on building in the first 4 or 5 years of this technology is a really robust state machine that's extremely scalable. And now we're starting to add a lot of the higher order bells and whistles around it in terms of dashboards, in terms of modeling editors, in terms of user interface usability, things of that nature.
If the task needs to be done by multiple human interaction, so you can partially work on your action, then you can go to assignment. Let's say I'm doing some partial work, then I want to assign to some other department. I can go here and assign to different group. Okay,
right.
Customer service, I'm the customer service. I did partially my work. I want to assign to different customer service department. I can assign to different group. User at a different group.
So your business rules to that point take their own life cycle. So you can create different logins based on different permission levels. If you have a line of business user who's an admin type, they could basically look at all the workflows that are going on and assign a certain workflow to a certain admin or whoever have you, or an operations person, and track that through completion. If you have 10 business processes that are in flight, 10 events that have happened, where VMs have spiked or whatever have you, you can click on each and see where they are in that flowchart. So you know where the bottleneck is happening.
Okay. So I'm done the work, so now I'm going to complete my task. So all the information looks good. I'm going to complete my task. Then this one, okay, it's completed.
Yep.
So now it goes to next node, which is,
Yep.
okay, so you did.
So this is where the task paused because it needed input from a human actor to say yes or no, which he just submitted. And then once you do that, the activity actually progresses to completion, which in this case is to call out your
I can
CloudForms.
show you that process instance where it's currently status. Okay, so it's completed. Yeah, you can show that.
Yeah.
So if you look at the management engine now, if I reload this, these are all the requests coming into the CMP now. So the BPMS basically said, okay, provision a new VM. And so what we've done is, you can see now that on OpenStack itself, I've got a pending request. So now if I go over to my actual Horizon dashboard, this is the OpenStack Horizon dashboard itself, and sign back in, I should see in a few seconds here, after this request goes through, I should start to see that VM provision request happening. So I could see each state of this happening in the actual CMP as well. So the BPMS is doing higher level business logic. The CMP is actually doing all the necessary work of clone the VM from a template, from Ceros in this case, the template that it's using inside of the OpenStack Glance image repository, spin it up, it could decide which networks to put it on and do all that. And basically the passing of information between the BPMS and the CMP can kind of facilitate this. So let me just see if this instance is now spawning over here. There it is. So now my new instance is spun up on my OpenStack environment. All right, last example, because we know we stand between you and beer.
Yeah.
So the last one is kind of placing workloads with business policies in mind. So you'll notice that, again, if we go back to this chart, right, we had this happening where we were telling the business user, we were giving him a contextual alert based on what's happening with a transaction processing system. We were requesting a new VM. The problem is here, which provider is PCI compliant, right? So if the cloud management platform doesn't necessarily know who Acme Corporation has signed agreements with, it doesn't know what kind of compliance from a regulatory and compliance standpoint those are running on. So basically what we want to show here is how leveraging the BPMS we could basically ensure that the VM gets placed on a compliant provider. So instead the request should come through and say, hey, please put this on Red Hat Enterprise Virtualization because maybe my OpenStack private cloud provider is not compliant.
So just to Jim's point, right? One of the use cases that we deploy this product in a domain like financial services. You have a pretty large mortgage management application which needs to service its users who are homeowners. And some of these homeowners are underwater. They've stopped making payments on their mortgages. And they call into an application, they call it a call center. And basically the call center agent has an application that they're looking at to see if the user qualifies for a mortgage relief or whatever, right? And if you look at the space, there's like 7 or 8 plans that they should take these users through. And there should be full auditability of what options are offered, what were taken, what were not. And if you look at it, this is fairly the kind of problem that you would run in a cloud environment too, where you have multiple clouds. Most organizations are now multi-cloud. We're starting to see the vision of open hybrid cloud become more of a reality. Organizations have VMware, they have Rev, they have Amazon Web Services, they're probably doing some OpenStack. You could basically define a hierarchy of your clouds and define these packages of what action to take based on what events happen, and put all of these in a string these rules together in a business process, and which is pretty similar to what's being demoed here, right? So the first 2 use cases are fairly simple use cases, but as you see with the third one, you can start building all sorts of interesting abstractions around your complicated, your workflow, which might be complicated in the real world based on how to place workloads and where, based on line of business, based on their ability to pay, what's a gold workload, what's a silver, what's a bronze, et cetera, et cetera.
Yeah, you don't need to bring down the server. You can do the changes anytime. You can
Right.
change the process and rules anytime without bringing down the server.
So to Jay's point, once if you change a business rule, you could do so using the portal, or you can do so using all the common access methodologies that we support, Eclipse being one. But it all works on being able to update these rules dynamically. So you don't have to change, you don't have to bring anything down. So the CMP is pretty decoupled from the BPMS, and they both operate in different domains. So I need to bring one down because of something else something's changed in the overall logic.
So you want to show them?
Okay.
Yeah, so I basically kicked off that last scenario, the CPU spike 3. So this is kind of the one where we don't want to place the workload on OpenStack. We want to ensure it goes on to Rev because we know it's PCI compliant. You're in as Jay, maybe, or you're in as admin here. Do you have to be in as Jay?
Yes, Jay. Did you start the
here.
process?
Yeah, here. There we go. Oh, wrong one. Maybe refresh that. No. All right, it's live demo time.
Did you start the process?
Yeah, I think so.
And this login itself can be tied into any LDAP or any compliant repository that you store your logins in.
Yeah.
There you go. All right.
So it's assigned to me, and I can go on the client my task.
So this is a task that's assigned to the user based on the event that fired, where you want to look at different clouds on which you want to tell the CMP. So it's essentially a round loop, right? CMP notifies the BPMS, and the BPMS now decides what to do and tells the CMP what to do. So the BPMS is the orchestrator or the brains behind the operation.
Okay.
So this is a guy who doesn't know how to use a Mac, right? He doesn't use a Mac. Neither do I.
Is it not letting
Yes,
you claim
yeah,
it?
claim the task, claim the bug. Yep. Yeah.
Yeah, it's not letting you.
Yep, claim it. Mm-hmm.
Yeah, it won't let you. All right.
Sure, please.
You want me to pop open Safari?
Mm-hmm.
All right. When in doubt, try a new browser, right? Go for it.
Yeah. Something's logged on, so.
All right. Well,
Let's talk through it.
yeah. So we'll get that one.
Yep.
We'll get that one straightened out. If you guys want to stick around, we'll bring in some beer and fix it. All right. So I'll let you close it out. So. Yeah, go ahead, Vamsi.
Sure. So if you look at what we're trying to achieve here, right, with the integration between the BPMS and CloudForms, there's a couple of different.
This is a good thing I can show you how we can see where the status of the process since it's stuck in the. Yeah, you can. Yeah.
Here.
Yeah, it's coming. Wait.
What's that?
Let me cover that before.
Yeah.
Okay.
And then we'll-
So the first thing is at the speed. Obviously, if you have events that happen in the IT domain, in the past you'd have to basically go into your CMP or whatever your virtualization management provider was, and you had to basically make those changes, right, based on things that change. Again, the issue is that the CMP is typically a system that's not tailored to BPM or rule-based management. So the speed of response time to events that happen in infrastructure is slower. Maybe it was manual in some cases, right? Or maybe your CMP lets you do a bare bones state machine. But using a BPMS and coupling that with CloudForms, a product like in the CMP space like CloudForms, helps you react to these events pretty fast in real time pretty much. And the second use is that it gives you more agility, right? In the end, it's all about the business. It's all about the business being able to use a certain workload. So the IT resources are pushed out to the folks that need them, the business, in real time, pretty much, based on spikes that happen in your infrastructure. So we showed you some stuff around human tasks, but you also could make this automated end-to-end. So if you have apps that scale in the day, sleep at night type pattern, you could basically have the BPMS auto-scale resources as needed. The third is accuracy. So all the logic that governs if a certain business process is called, what rules were invoked, are all stored in an audit log in both systems, but also in the BPMS primarily, so that you have complete governance capabilities on if a certain regulation was there or a certain mode of operation was agreed on by IT and line of business, was that respected, right? Your full audit tracking, and you have also an ability to fix a process that you think might be broken or didn't respond right. And it's all in the end about empowerment, right? We all talk about application-driven cloud, and the fact that enterprises are basically doing a lot of plumbing by figuring out what cloud they want to go on, which is the way it should be, right? It's all good stuff. A lot of good action on open source with OpenStack and some of the stuff around CloudForms and other projects. But again, in the end, it's the business that is going to dictate what workloads go on the cloud that you build. And with PaaS and DevOps, you're moving to a model where developers can basically go to a portal, request capacity, and get it as fast as they would on EC2. In the end, it's about empowerment and making sure your apps are doing the right thing for your business.
Thanks, and
Thanks, guys.
Yeah, thanks.
Thank you.
Okay.